Class define a structure consisting of field, methods, and properties. Instance of the class are called the object. The field, method, property of the classes are called its component or members. So field essentially a variable that is part of the object. Like the field of the record, field of the classes represent the data item that exists in each instance of the class. And method is method is the procedure or function associated with the class, right? Most of the method operate on the object, that's the instance of the class. Some method that is like class method that is called by the class, right? So no need to call by object of the methods. Property is the interface of the data associated with the object, often stored in field. Property have access specifier which is determine how the data is read and write, right? So that we can create a private member variables, and through property we will able to access it. From the other part of the program outside of the object itself, the property appear in most respect like a field. Now we will see that that code, how to create a class in Delphi, how to create an object, how to call the members of the class through object, right? And how to free the object after that. So let's take one example. Now we will. I have created one program, okay, and Windows VCL application program, and let's create one class here. So we can create a class like test. We can give any name, right? T is the prefix, just the standard that we follow, right, in Delphi. If you don't write, also not a problem. But if you write, that will be, that's a better, right, for the readability purpose. So T test equal to class, right? And after that, we have the accesses specifier for that class, right? So we have five accesses specifier. So private, strict private, protected, strict protected, public, and published, right? So this is how we can create a class, right? And after that, we can write in any of the specific section, right? Specifier, we can create a procedure here, okay? So info and control shift C, we'll go to the definition part. So just I'm showing the message here. So message, test of class and object of that class, right? Now we need to create an object of this class to call this method, right? So we need to create an object of t test. So just on the form create, okay, just on the click of the form, I'm just creating the variable of, we have to create the variable, object is the variable of type t test, right? And now the object is the variable of type t test. Now we need to create it and assign to obj. So how to assign t test test dot, we need to create it like this. So what we did, we have created an object, okay, and we have assigned to the this variable, obj variable, right? So now memory is assigned for this. Now we can access our variable, right? So obj dot, we can see that control line space. We are seeing all the methods, right? All the members are coming from that class, right? So info is one of the method we have created. We can call it here, and after that object dot free, right? So we have to free the memory. So this is the two like way to free the memory, and there is the other way, free and nil, right? So best approach is write the free and nil, okay. So I will create one more video on the free and nil, what is the difference, which one is the better, right? So that will come in the later video. So as of now I'm writing the free and nil, right? So what I did here, I have created the variable of type details class, and after that I'm creating the object of the class and assign it to the object variable obj variable. And after that, from the obj variable we can call the all the class member, right? So I'm calling the so info. So this is the way we can create a class and we can create an object, right? So this is all about the class and object in Delphi. Thank you. What is the inheritance and how it work? So inheritance is important player of the OOPS concept in Delphi. An object-oriented programming, inheritance is the other type of the relationship between the classes. Inheritance is the mechanism of reusing the functionality of one class into the other class. Inheritance is a relationship. Now, in later we'll see that what is a relationship. The class from which a new class is created is known as the base class, right? That is also called the parent or superclass. The new class is called the derived class, and that is called the child class or subclass. So that we know that inheritance is a relationship. In a real world example, a customer is a person. In the same way, a student is a person also, and employee is also person, right? So we can say that the student, employee, all are, and customer are the person. They all have some common things. For example, they have the first name, middle name, last name. So to translate this into the object-oriented programming, we can create a person class with the first name, middle name, and last name. Inherit the customer, student, and employee classes from the person class, and that's way we don't need to create a same variable or property into all the child classes to avoid the violation of the do not repeat yourself principle also. And here is the graph shown. The person, first name, middle name, last name. Okay, this is the base class or parent class. We can say that, and then from this person class we can derive the employee, student, and customer class, and these are called the child classes or derived classes. Let's take one example. So here I have created a class that we have discussed the person class. In person class, we have declared the first name, middle name, and last name, right? And just I have created a function get person full name, and return type will be string. So it will return the full name of the person. Now I've created a child class T employee, and that T employee will derive from the T person class, right? So if you're deriving from the T person class, all the property and method will be available to the employee class, right, of the T person class, right? So in T employee class, some more features we have added like employee ID and company name and get the full employee name. One method is there that will return the full employee name, right? What we are trying to do here, this is the parent class T person. We have some set of the property and method, right? A set of the variable and method, right? And from the T person we are inheriting the T, we are inheriting into the T employee class, right? So that T employee is a person, right? That we previously we have discussed is a relationship. So T imply is a person, right? So T imply will have all the like first name, middle name, last name, and they get the person full name. These are the variables and functions available in the T imply class because T imply class inherit the T person class. Now we will give the definition of the get person full name. So here just we will show the message, right? Just return it. First name, concatenate middle name and last name. And when it come to the employee, right? Get employee full name also. We will just return the employee full name, first name, last name. employee ID and company name, right? On the form create, what I'm going to do, I'm going to create an object of, right, T employee. So T implies what? This is the child class, and this is inherit the T person class, right? So T employee class, we have all the first name, middle name, and last name, get person full name method, right? Available, then employee ID and company name along with the get employee full name, right? So I've taken the variable employee object of the employee type, right? I'm creating the object and assigning to the employee object. After that, in the employee object, if you see that I have the first name, middle name, last name. So employee object, the employee class, we don't have the first name, middle name, and last name. It's available only because of we have inherited the person, T person class into the T employee class, right? That's why in T employee class object, the first name, middle name, and last name is available. So just I'm assigning the some value, right? First name, middle name, and last name, and employee ID and company name, right? And I'm just calling the method, okay, with the object dot get person full name. So when you call that the get person full name, it will go and call the this method, right? T person get per T person class get person full name, right? When you call the object dot get employee full name, right? Employee object dot get employee full name, it will call the child class employee method, right? Get call. So let's run and see what is the output. So we can see it here. Here the object dot get person full name, we are getting the Rohan Kumar, right? And next is we will get called that this is 70 line number employee object dot get employee full name. It will give you the employee full detail, right? So employee name, first name, middle name, last name, employee ID, and company name, right? So this is all about the inheritance. So we know that the encapsulation is one of the most important pillar of the object-oriented programming concept. And in Delphi, we will write one sample code, and we'll see that how to implement the encapsulation, right? So in picture, we can see that the capsule that contain the variable and method, and that overall the capsule is called the class. And the process of the wrapping the data in the function, right, or method that perform action on the data in a single entity is known as the encapsulation. So let's see it here how to like implement the encapsulation. So data encapsulation can be implemented by declaring a variable as a private member, right? So we know that in Delphi we have two types of private member. One is the strict private, that is the private member, and we have the protected members also, right? To restrict the direct access from the outside of the class. So we can avoid the access of the data members from the out of the class, right, directly through the object. So for this, what we need to do it, we can define the like public setter and getter method or property to access the private variable from the outside of the class. So we'll not allow the data type, right, or variables to access from the class directly, right? Any of the variable can be accessible through the getter or setter method or through the property, right? So that we can validate and we can do the validation over there, right? So that user cannot change the right wrong value to the variable. So just few more point I have mentioned over here. Keep the internal data and the code safe from the external manipulation, right? That we already talked. The user only know how to use the object, but the actual implementation, like how and where the data is actually stored, is hidden. The process of the wrapping the data and the function that perform the action on the data into a single entity is known as the encapsulation. A single unit is performed to as a class. Encapsulation is the process of like encapsulating the something in the capsule, right? so that we have seen in the picture. The encapsulation is the process of the encapsulating something in the capsule. It's protect the data and the code from the outside intervention. The main purpose or usage of the encapsulation is to guarantee security for a class data. To secure the data, we must employ the private access modifier, which limit access to the data outside of the class. So we make it private, right, or protected of our class data member, and that will be no, that we can limit the access from the directly from the outside of the class. The access modifier are used to specify the level of the access or scope of the class members, such as the data member and function. So here a few more points I mentioned about the encapsulation in detail, right? So this is one of the UI application. In this, I have created one form, and in this form, right, I have created one class. So this is the bank account class, okay, and in this bank account class, I have created one strict private member, okay, and this is the account balance, and two public function I have created here. The function check balance and the set balance, right? So what we are trying to do it here, we'll protect this account balance from the outside world to access it directly and change the value of the account balance. So account balance only will be accessible through the getter and the setter value, right? Setter method, so that we can do the validation in that method whenever user will change the value of the account balance, right? So what I'm doing in the check balance, suppose I want to check the balance of account, okay, what we'll do it, we can get the return of the account balance, but we can put the validation over here, right? If some validation if will pass, then only it will return the balance account, right? Otherwise it will cancel the message. So we can't get the value, right, or set the value. So we can't get the value directly, we can put some condition over here, right? The similar in the set the balance, if I want to set the account balance, right? So set the balance will be the procedure and pass the one parameter, right? And what is the balance you are going to set it. So in this set procedure, here I'm doing some validation. If balance is whatever the balance we are going to set it, if balance is greater than equal to zero, right? Then set the validation. Otherwise, show some message, right? So such kind of the validation we can do it in the getter and setter method whenever user is trying to change the value of the member variable, right? So this is called the encapsulation. We are hiding, right, directly to change, allow to change the value of the private members, right, or variables of the class, right? So only it will be accessible through the method, or we can create a property also here. Through property we will get the getter and setter method. So only from that property we will able to change the value, right? So what I'm doing, I just on the form button click, okay, account info, I'm just creating the object, and here what I'm trying to do, just see that I have taken the variable of the object bank account of type the bank account, right? And after that creating the object and assign to this value, this variable object bank account, and then bank account dot check balance. If I have to check the balance, right, what is the balance as of now I have. So and that we are showing the message. And similar with the set the balance. So during the setting I'm passing the value, right? So whatever we need to set it the balance. So it will go here and check it. If the balance is some condition, it will pass, then it will set the balance, otherwise it will prompt the message to the user, right? And after that free and nil. So main concept is here, we need to understand it. We are not allow our member variable, right, value to change directly from the outside, right? This, right? So it will be this variable will get changed only through the method, right? Getter and setter method. So this is the getter method. We can say this is the setter method, or we can create a property also. So through the property, we are allowed to change the account balance, right? Variable value. Okay. So this is all about the encapsulation. So if a class has at least one abstract member, then it will call the abstract class. An abstract member is a class member that has only the declaration in the class, and the implementation of that member are expected to be done in the child class or descendant class. An abstract class can have the normal method also, because when we create a class, in that class we can have at least one abstract member, and we can have non-abstract member also, right? So if we have at least one abstract member, then it will become the abstract class. We can create an object of the abstract class, but we should not create it, because when we try to access the abstract member, then we will get the runtime exception, right? So that we I have shown it here. So this is the abstract error message will come, right, when we try to access the abstract member from the class object. If you then try to call this method, Delphi will try to call the abstract error prompt, and if it is not found, then it will throw the e abstract error exception. So here I have created one UI, and in this we'll try to understand how to create the abstract member. So I have created a class here, and a t abstract class employee, and equal to class. So this is the class where I have declared a private member name, and public member procedure get info, and the other procedure is the test for the abstract method. This is the one of the method I have declared, that is the abstract method. How to declare abstract method is, first we need to write the, after the method name we need to write the virtual or dynamic, and then the abstract keyword, right? So this method will become the abstract method. So we can't give the definition of this method into this class, right? If you see that control shift C, it will not work out. It will not go and create the definition part. So abstract member we can't define it here. So that means when we will inherit this abstract class, right? So why it become the abstract class? Because at least one member of a class is the abstract member, right? Abstract member, right? So the class itself become the abstract class. So now this class has become the abstract class. Now in the next class I have created the child class, right? And this I am trying to inherit the abstract class employee. So this class I am trying to inherit into the child class. And if I am inheriting, I have two options. Either I can, so first thing is, when we are inheriting this class, right? So if any of the abstract member is there, we have to either override, or we can keep this method again as a abstract method, right? So again in the child class only we can override this method. Now let's see that when I'm trying to and I've given the definition in the get info, I've given the logic just showing the message, right? And after that, the child class, here we can give the definition of the this method, right? Test for abstract method. So here just I put the message, right? This is the child class test abstract method call. Now what I'm trying to do, so I'm going to create on the button click, on the abstract class button click, I'm going to create the object of the t abstract class employee. So here I have created the variable of the t abstract class employee. After that I'm creating the object assigned to object. Just I'm assigning the value to name, and after that I'm calling the, with the abstract class object I'm calling the get info, because get info is not the abstract method, right? It's a normal method, so we can call it. But when you try to call that object dot test for the abstract method, right? So test for the abstract method is what? Test for the abstract method is the abstract class, right? Abstract member. So so we can't access this one, right? This method from the abstract class object. So here it will give the error. So just let's compile, right? We are able to compile. Just run it, and just click on this, because on the button click, abstract class button click, it is so here I am able to run it here, because this is non-abstract method, right? for the abstract class employee, right? But when you try to access this abstract method, then it will give the error. So if you see that here, this abstract error message is coming. So that's why you say we can't access the abstract method of the abstract class object through the abstract class object. So whenever we have created the abstract method, right? So definitely that method we need to override in the derived class, right, and give the different definition of that. And that's a way we use the abstract class, right? So the purpose of the abstract class is like something common is there, right? So if I want to create the object of the child class, now we will able to call this method, right? So we will create the child object of the child class. So here I'm creating the object child class, variable of the child class, the child class. Okay, I'm creating the object. Let's write here, creating the object. Now I'm trying to access. I'm trying to access the method, right? So it's for the abstract member. So that we will able to access here now, because this is the overridden method in the child class. So this here we have given the definition also, so it will display. So let's run this. We'll first comment this, because here we'll get the exception. Now if you see that, now we are able to get info, and that's from the child class object we are able to access. We are able to call the test for the abstract method. So abstract class is the class where right, it's not fully contract. So we have some of the method are abstract, some of the method are not abstract, right? So the method which are abstract, that we need to override in the child class. That's all about the abstract. What is the interface? How to use it? And we'll take one example to understand the interface implementation in Delphi. The interface is a type, just like a class is the type. Like a class, interface also have method, and whenever the interface we implement or inherit into a class, we have to give the definition of all the methods that are available in the interface. Interface offers some of the advantage of the multiple inheritance without the semantic difficulties. A class can implement multiple interface, right? So that way we achieve the multiple inheritance in Delphi, right? Because we can't inherit the multiple classes in any of the class. So we can inherit multiple interface in a class. The type interface is also a type, so interface name equal to interface, and we can write the ancestor method. So within the interface we can also inherit the interface, right? So in a interface we can also inherit interface, and after that GUID, globally unique identifier, and we can declare here the list of the members, right? All the members are all the procedures method, right? That we can say that the function and procedure we can list down here. So as we know that interface we cannot give the definition of all those method, right? So we have, once we will inherit that interface into a class, we can give the definition of those method. Member list can include only the method and property, because field are not allowed in the interface. Since the interface has no field, property read and write specifier must be a method. So through read and write, only through method we can get it. All members are interface are public. Visibility specifier and storage specifier are not allowed. Interface have no constructor and destructor, because interface we cannot create an instance of the interface. So and the destructor is not allowed, because interface have the mechanism to destroy their object. They cannot be instantiated. Interface cannot be instantiated except through the class that implement their method. Method cannot be declared as a virtual dynamic abstract or override. Since interface method cannot be we can't give the definition, we cannot write the logic in the interface methods. So there is no meaning of declaring a interface method as a virtual dynamic abstract. We have the calling convention for the interface also, like how we have calling convention for the method. So similar way we have the calling convention for the interface. The the default calling convention for the interface is the register, but the interface shared along the modules, right, should be declare all the method with the std call. Interface property is there, and forward declaration also we have. An interface declaration, forward declaration, how we have the class forward declaration. So suppose we can declare any of the interface, right. Suppose without before declaring the interface, right, we can use that interface in any of the interface, right. So we can declare like this, suppose I'm declaring interface I control, right, equal to interface. We are not writing any of the method of this interface I control, but later we will write the method after the I windows interface. But I control interface reference we are giving in the I windows, right. So before actual uh, declaration of the interface, we want to use that interface into some other interface, then this is called the forward declaration. And class declaration, how to declare a class, and then we can inherit the interface. So like we can write a class name equal to class, and we can write all the interface. So to inherit the interface, we have to use the t interface object class, we need to inherit it. Let's move to the Delphi part, where we will try to understand the interface, how to write, how to inherit the interface in a class. So here I have created one UI application, just one button, and button click we will try to access the interface. So I have created one interface, test interface one equal to interface. This is the one in, this is the my interface, and in this interface I have declared a method get info one, right. The second interface I have declared here that I test interface 2 equal to interface, and get info 2 is the method, right. Now I have two interface, and I'm declaring a class t imply class where I'm going to inherit these two interface. So what I need, t imply class equal to class t interface object is the, this is the this is the inbuilt class where there uh, that memory management of the interface is written. So there is the basically three method, right, is there that we'll discuss. I interface object, here I have, here I'm inheriting I interface object, I interface 1 and I interface 2 to interface I'm inheriting in the t imply class. And suppose we are inheriting the I interface 1 and I test interface 2, right. So these two interface method also we need to write it here and give the definition, that is must. So I interface 1, I test interface 1 method we have get info 1, right. I test interface 2, the method name is get info 2, right. So this method also I have written in this class. Now we have to give the definition of this. So just I have mentioned the so message I'm putting, okay, so that we can understand it when we call it, which method is getting called. And on the button click, just on the button click, will try to access. So I have created an instance of imply class. So t-imply class here, I have taken a variable object of t-imply class. I am creating an instance of the imply class here and assigning to the object, right, obj. And after that obj dot, I am trying to access. So I'm able to access these two methods that is available in the t-imply class. Get info one and get info two, right. here I am able to access. Let's run and see how it is working. So here we are able to fetch the get info 1 and from the employee class get info 2, right? Now what we'll do, we can take a object of interface type also, right? So suppose I am taking the iInterface object 1, okay? Declare a variable of iInterface 1, right? And I can create an object of t imply class and assign to this object, right? And this object is what now? It's a type of I test interface 1 type. Now when I will try to call with this object obj, we'll able to access only the get info 1. We'll not able to access the get info 2, right? Because this is the object of type of I test interface 1, right? So it's a static time it will define. So we'll see it here. I test interface 1. We have only one method get interface 1. That's why we are able to get here with the obj. We are able to get only the get info 1. So this get info 2 is not accessible, and the free and nil is not required because the this is the object of this variable is object of the I interface. So interface we don't have any constructor destructor, right? Because the memory management it do it internally. So for this, we have the three interface that is declared into the T interface object. So it manages the memory object reference. Okay, let's run it. So here we are able to access the get info, right? This is the one, not two. So this is all about the interface. So what is the polymorphism nodes concept? Okay, and how to use it? We will take one Delphi example. So polymorphism is derived from the two Greek words poly and morph. The word poly means many and morph means form. So we can say that polymorphism is poly many forms, right? The overload directive allow you to have different version of the same name, function or procedure with the different data type argument. Okay, order of the parameter, sequence of the parameter. The function return type does not matter. Okay, so we can have the same name method, right, with the different signature. So signature means the number of the parameter, order of the parameter, and sequence of the parameter matter. Return type of the function doesn't matter. Okay, so there are the two types of polymorphism in Delphi: compiled up polymorphism and runtime polymorphism. Okay, we can perform polymorphism in Delphi by method overloading and method overriding. So what is the method overloading? The overloaded directive tells Delphi that you will declare another subroutine with the same name but different parameter, or we can say that with a different signature. If you use the overload directive in the method declaration, it must appear before the virtual dynamic or abstract directory. You can declare any function, procedure, or method with the overload directive. You can overload a method in the right class, even if the method with the same name in the base class and does not use the overload directive. An alternative to use overload method is to use the default parameter. For the parameters with the simple type, default parameters usually result in less code to write and maintaining. For complex parameters such as the object, you might find it easier to write the overload subroutine that call each other. The compiler uses the type and the number of the actual argument and sequence of the parameter to determine which overloaded routine or which overloaded method to call, but the return type does not matter here, right? So in the overloading, one concept is there: return type of the function does not matter, only the signature matter. So how the two method with the same name but signature is different, right? So signature is different means number of the parameter is different, or if the parameter is same, then sequence should be different of the parameter, right? Or the data type should be different for the parameter. So here I have created one class, right? T student class, and in this two student class I have written a function student detail. Okay. So student detail, what I'm passing the name, I'm passing the roll number. So name is integer type parameter, roll number is integer type. Sorry, name is the string type parameter, roll number integer type parameter, and student annual fee is double. Okay. And similar way, I have given the same name, right? Again, the student detail, but parameter number of the parameters same, one, two, and three. Total three parameter I'm passing. Okay, right? Return type is also same, but we know that the return type doesn't matter in the overloading concept. Okay, it could be integer, it could be float, right? Or in any other data type, it could be, right. But this follow the overload concept. Okay, because of, if you see that the student number, right, student number is there in this and in the previous method also, name also available in the previous method, student annual fee is also available. But you see that the order of the parameter in the second method, right, is different. So first order is the student roll number, right? But if you see that the first student detail method, name is the first parameter. So that's why this is the overload concept applicable here, right? Because what I said, the method name could be same, okay, but the signature, whatever we pass, right, it should be different. So signature, we can say that the number of the parameter should be different. So in two method, maybe one method can have two parameter, and other method we can have three parameter. So in this way, differentiation should be there, right? Yeah. So here we have the same number of the parameter, three parameter we are passing, right? Data type should be different. So if you see that the name data type is here also string, student roll number is also teacher, student fee is double. So here also both are matching, right? The data type of the parameter is different. But if you see that the sequence of the parameter is different. So here first parameter is name, right? Here the first parameter is student roll number integer type. So sequence is different. That's why this is the overloaded concept here applicable here. Okay. So here everything is same. Both the function name is same, but only this sequence of the right parameter is different. Okay. So that's why these are the overloaded method. So now we can just give the definition of this. Okay. And just I'm just showing the message, getting the student name, student roll number, and displaying the annual fee, right? And how to call this method, right? Because the name is same for these two methods. So I have created an object, okay, of type student class, and this object I'm assigning the memory, okay. And after that, what we can do it. So I'm creating the object of the student class, right? So object dot now we can able to access these two methods. Student detail, both are same name, but if you see that the parameter for this different, right? So student detail, the first one is the name, student roll number, and student annual fee, right? Second is the roll number first, name, and then fee. Okay, so we need to pass this, and on that basis of the parameter, right? The first parameter is name, so I'm passing the right Bajaj. Second parameter is for me roll number. So roll number is suppose one one one, okay, and third parameter is annual fees. So I'm just putting the 10,000, okay, 10,050. Yep, 10,060 paisa, right? Now next is again we have the two method, right? So this is we have called it this method actually, right? But with the different nature, different arrangement of the parameter, we have one more method, right? The student detail provision, that is student detail, right? I need to pass now the integer first, right? So what will be there? Suppose I'm passing this, then then a string name, right? Pass this name, like Mark, okay, and next parameter will be, okay, and now you can call it. What we will do, we will just run it and see what is the output. F8. This is message printing. Here also message printing. This and with object, right? So method binding can be static, the default, and it can be virtual or dynamic. The virtual and the dynamic method can be overridden and they can be abstract. These, de- these designations come into the play when variable of the one class type hold the value of the descendant class type. They determine which implementation is activated when the method is called. So at runtime it will decide which method will get called, right? Method or default static. When the static method is called, the declared compile time type of the class or object variable is used in the method call determines which implementation is activated. So in the static binding, it will determine which the class variable we are creating the object. So here, for example, I have taken created one class tfigure class and draw method. I created one t square class and we are inheriting the tfigure class here. Okay, the same method. I'm writing the draw method here. Let's talk about the virtual and dynamic method. So virtual method are enabled subtype polymorphism. In other words, they allow implementing the different behavior in the descendant class. So what will happen? Suppose the same method is written in the parent class, okay, as a virtual, and in the derived class, the same method. If you are writing as a override, right? So that means we are giving the redefining that method into the child class. So that means if we have the base class T shape class with the virtual method paint method, okay. So suppose we have the T shape class with the virtual T paint method, okay. And in the descent class, like T rectangle, circle, or T triangle, we are inheriting the T shape class, okay. Then each of these subclasses can implement a different paint method to appropriately paint itself. So in the rectangle, the paint definition will be different. In circle, paint will definition will be separate. In triangle, paint definition or paint logic will be different because in the triangle it will paint will be different way. Okay, so you can call the paint method on any shape, right, instance without needing to know which kind it is. Okay, and it will be correctly painted. You should almost always use the virtual directive instead of the dynamic one. In the most cases, the virtual method are faster and take less memory than the dynamic method. So here I have created one class, T my parent class. Okay, in this I have created one procedure one is the virtual. Okay, and the procedure two. This is the static method. So I have not created as a virtual. This is just a normal method. Procedure two, right? I have created one child class, T my direct class, okay, and inheriting the my parent class in this. Again, I'm declaring the procedure, okay, one, and I'm overriding here, okay. But in the procedure 2, I'm not doing anything. So this is the static loading. But in this case, what will happen? It will be the dynamic loading. Okay. So what I will do on just on the and I have print the message for each and every method, right, in the definition part, so that we'll understand which method is getting called, right? So on the button click, okay, just on the button click, I'm creating an object, right, of the TD right class. Okay. So first, what we will do? First, we will do. Uh, uh, so I have created the variable of the T derived class. Okay, and created the variable of the T parent class also, right? And I'm creating the object and assigned to the derived class object, and creating the parent for the right assigned to the parent class object. So both the object is created for with the my derived class and the my parent class. Okay. From the parent class, if I'm trying to access, okay, my parent class object, I'm trying to access the one method, okay, and two method. What will happen? And from when the derived class, if I'm trying to access the one and two method, what will happen? Okay, and just we'll take this much example first. Okay, let's run and see it. So let's run and see it. Yes, I'm running it. Click on the dynamic handle. We'll see that how the code is executed. So just I press the F8. Okay, so object is created. Okay, the parent class object and derived class object is created. From the parent class object, I'm calling the one method. Okay, so what I will do, I will just put the breakpoint over here. Okay. So for each and every method, put the breakpoint. So what is happening here? When I click the F, then I press the F7, it is going to the my parent class one method and showing the message to us. Okay, this is the my parent one class call. Next is when I'm calling the from my parent class object two method, what will happen? It will go F7 and it will go to the method. It will show the my parent class 2. Why it is happening? Because the my parent class, I'm just creating the object and trying to call these two methods. Okay, so it will be the setting, right, and it will execute whatever the code is written inside the method, right? Now let's try to call the one method from the derived class. Okay, so here I am, and now my cursor is here, F7. It will go here, and you can see that inherited. So what will happen? The my derived class one is the we see that the definition my derived class one is the override method. Okay, so what it will happen? It will go to the inherited method first, because of the this it will go to the inherited method of first. So inherited method of the child parent class, right? So it will go to the first parent class one method, right? It will go here first, and then it will come once again in this method. So if you see that effect, it's calling that the one method of the my parent class. Okay, then it will come inside the same method, and it will execute the my derived class one method. So first, what it did inherited, because of the inherited, it is going to the parent class one method, and after that it's executing the child class one method. It start executing. Okay, similar way. Now here the child class method logic is executing. Then next is the when I'm trying to derive class 2 method, right, what will happen? This is the derive class 2, right? It will come here, effect, and then this message will print, and after that it will go here and create the object. So what we have seen it here, when the method is overridden here, right? When the method is overridden, right? So here in the my parent class, one method procedure one is the virtual. When we are inheriting in the child class, my derived class, we are inheriting my parent class, right? One method we are overriding. So overriding means we need to give the different definition of our class method. Okay. So When you go to the definition of the one method, right, what it will do here in the inherited keyword will come. Inherited keyword means it will go to the inherited, right, the class member. Okay, so it will go to the inherited one method, inherited class of the one method. So it will go first, inherited class of the one method will be the my parent class dot one method. It will execute this line, and after that it will come and execute the set up the logic whatever written in the my derived class one method. Okay, so this is the difference, and it will decide at the runtime. So which method, right, object we are going to call, which class object is going to call. So what we will do it here, we will take one more example here. Suppose I have created an object here, okay, and let's comment and see it. Okay, let's close it and see it. Just let me create this one. Okay, so what will happen? Suppose I am creating a child class object, okay, and assigning to the parent class, right, variable of the parent class. And I'm creating an object of the derived class, okay, and assigning to the variable of the parent class. Now if I will try to access, okay, if I will try to access parent class turn one method, what will happen? And again two method, right? So you'll see that what is happening here. So just compile this one or build your application. Just put the breakpoint over here, run the application. Now we are creating the object of the derived class and assigning to the variable of the parent class type. Okay, f8. Now if I try to call this method, because one is the virtual method, right? So what will happen? It will go to the derived class. Okay, it is not going to the, the variable type we have declared, right? So this variable is the type of the parent class, right? But the actual this variable is assigned with the child class object. Okay, so it will go to the child class, okay, one method. It will not go to the type of the variable we have declared of the class. Okay, it will call the method. The class is created, right? Okay, that's matter here. So we have created the class of the derived class here. Okay, so when you are calling the one method, it will go to the derived class one method, okay, instead of going to the parent class one method. So here it will go and call the, because they inherited, it will go and call the parent class one method, and then execute the child class logic. Okay, and in two method, right, what it is simply it will go and call the parent class, right. It is not going in this case to the child class. So whenever the method is overridden, right, in this case, if you create an object of the derived class and assign to the parent class variable, and if you try to call the overridden method, right, override method with the parent class variable type, okay, then it will directly go to the derived class one method, right? It will not go to the parent class one method. So this is all about the dynamic binding. Hi everyone. The reintroduce directive suppress the compiler warning about hiding the previous declared virtual method of the parent class. So here I have created one employee class, okay, and the method get info is here, okay, and that is declared as a virtual method. And the employee detail class is there, and that is inheriting the t employee class, okay, and the same method I have written, but I'm writing here the reintroduce keyword. Okay, so what it will do, it will suppress the compiler warning, right, about hiding the previous declared virtual method of the parent class, right? So it will, because of the reintroduce, it will suppress the compiler warning, right? And it let you tell the compiler that you did not accidentally create the method with the same name as a virtual or dynamic in the ancestor class, right? So this method is not intentionally accidentally created. Okay, so that's indicate. Let me show you the code. Okay, so how we can write the code in Delphi. Okay, so here this the same thing, like imply class I have created and get info with the virtual method, and then I have created one child class inheriting the employee, right? And the again the get info same method is there that is available in the parent class method. Okay, but here I'm writing the reintroduce. So how it will help, we'll see in the code. So same thing I will show in the Delphi ID, right? So if you have a child class that contains the function with the same name as a virtual function in the parent class, and it is not declared with the override modifier, then it is a compiler error. Okay. So adding the reintroduce modifier in such situation fix the error. But I have never grasped the reasoning for this compiler error. Now we have one of the two choice to suppress that compiling compress the now you have one of the two choice to suppress that warning message. First thing is we can introduce the reintroduce keyword, we can use it. Otherwise we can override that method, right? That is declare the same method that is declared as a virtual or dynamic in the parent class, right? Let's take one example. And so here what I'm doing, first I have created an employee class, okay, and the get info method is there, that is the virtual method. So it could be the virtual or dynamic method, both will be right. Uh, Both we can take it. And the next is the employee detail class is created, and that is that in that we are inheriting the employee class, okay. And again the same get info method I have written here, okay. If I just simply compile this application, what will happen? Just I'm compiling. If you see that there is the one warning message, okay. What is that warning message? The get info hide the virtual method of the base type tmply. So method get info hide the virtual method. So what it's saying? So method get info, this method will hide the virtual method of the base class tmply. Okay. If you put the reintroduce keyword here, okay, what will happen? We'll see that. Now I'm putting the reintroduce keyword after the function name. Okay. Now let's compile and see it. Then this warning message is gone. Now whatever earlier it was showing without the reintroduce keyword, right? So we see that no message is there. So that is what the message is prompting. To suppress that message, we are putting the reintroduce keyword here. Now let's on the form create. Just I'm giving the on the each these are the two method, right? Get info and the get info of the employee class. Okay, just giving the definition. So just printing the so message so that we will get to know, right, what is the which class method is getting called, right? And in the form create, I'm just creating the object of, right. So I'm taking the variable of the employee t employee type class variable, okay, and I'm creating the object of the employee detail, okay, and assigning to the employee type variable t employee type class type variable, okay. I'm assigning with the t employee detail class, okay. And when we will call this object employee dot get info, what will happen? It will not call the employee detail get info method. Okay, it will call the employee class get detail method, get info method. Okay, and here I'm freeing it. So just let's see and say it. So what basically it will get called? It will get called the employee get info method. Okay, so just I'm running and we can see that. So get info method of the employee class called. Okay, so here it is not calling the employee detail get info method. Okay, so this is the kind of static binding. Okay, so whatever the class we are taking the variable. Okay, class type variable, that class type, that class method is getting called. It's not it doesn't matter which class, right, you are instantiating. So this is all about the reintroduce. So what is the constructor? So constructor is called whenever the constructor is the method. Basically, it get called whenever the instance is getting created. So instance basically the whenever the class object is getting created, it will get called, and destructor will get called whenever the object will get free of the class, right? So I have created here the T product class, and that I have taken the two variables, the str list of the string list type and product name of the string type. Here I have declared the constructor and we are passing the parameters. So whenever we create the class object, at that time we'll call this create method and we'll pass the s name so that we can initialize the variable right of the T product. And there is a destroy method, so that destroy method whenever the class object will get destroyed, at that moment it will get called. And there is one procedure to set some list, so that through this procedure we will add some of the list into the string list object, right? So in the this class create method that what we have written, so when it get called, right, so here form create, on the form create, I am creating the, I have taken the object of T product type, right, and I'm creating the instance, right, I'm creating the object and assign to the obj variable. So what I'm doing here, this is the class that create, this create constructor is getting called with the parameter, right? So I'm passing this test for the create, and this will go to the s name, right? So when you call this create method, it will go and assign to the prod name, right? And after that, just I'm creating the t string list, right? And whenever the, then after that we are calling that object that set some list, and set some list, what it's doing, just we are adding one of the string, and then we are freeing the object. So when you free the object, right, or free and nil, basically we follow. So when we call the free and nil, basically it will free the object and set the reference of the object to the nil. So it will call the destructor method. So this destroy will get called, right? At that moment we can write our logic. So let's run and see. So I'm running, and what we are going to do, let me just put the breakpoint here. Yep. So now I'm going to create the object here. So press F8, it will go and in this create method. So this name will get assigned, whatever the value is coming, right, to the product name. Product name is just a variable in the T product, right, class. And after that, we are creating the object of the T string list, right? And next is it will come to the object that set some list. So set some list, it will go and it will set some list, right? After that, it will come to the free and nil object, right? So it will try to free and set the reference of the object to the nil. So it will go and it will, when you hit this free and nil, it will go and call the destroy method, right? So here it will check the if it is assigned and the this object is string list object, then it will free it, right? and finally it will come out. So this is the use of the constructor and destructor and how it is when it is getting called, right? Whenever the class object is getting created at that moment, create constructor will get called, and whenever free that object at that time, destroy method will get called. So class access specifier also we say. So every member of the class have the attribute called visibility, which is indicated by one of the reserved word private, strict private, protected, strict protected, publish, automated. So each and every class member have some kind of visibility, right? So when you try to access that class member, so depending on the visibility, it will be accessible in within a class, outside the class, or outside the unit. The private member visibility outside the unit program where the class is declared. So we'll see this through the example. So we'll write a code, create a class, and we will put all the access specifier. So here I have created one class, and in this I have created one test class, right? And I have written all the six accesses specifier: the strict private, strict protected, right? Public and published. In for the just to explain, I have created one variables. Okay, that is a string type variable for each and every access is specified. Perfect. Now we will, and I have created one method to display the member accessibility. This is the procedure, public procedure, right? So we will try to access with this procedure. So this procedure is within a class. So we will try to access all the access specifier within a class method, right? You will see that what is the visibility, which are the access specifier data we are able to fetch it. And after that, we will see that outside the class members, right? We are able to access this class all the variables. So outside the class, that I mean to say that on the form create or some other class members, right? When you inherit this test class into some of child class, so through that we'll try to access. Then we'll see that the what are the accessibilities there. So let's see with the display member accessibility, right? So this is the display member accessibility. So in this method we will try to access. So just I have created an object. This is the variable of the test class, okay, and just I'm creating and assign the to the test variable. After that I'm trying to access the object test, right? So here I'm able to access all the fields. You see here we are able to access the strict private, right? Private field, strict protected field, and public. And after that we will select the publish. So all the six accesses where we are able to access within a class member, right? Now we'll try to access on the form create, right? So just on the form create, we'll just create an object, okay? Uh, and after that we'll try to access. So we'll see that the outside the class, right? From any of the method, we are able to access only the private, protected, public, and public. So we are not able to access the strict private and strict protected member, right? Outside the test class method, right? So this is the conclusion here I have mentioned, right? So this is I will take the example, and we will go and create other unit. So that unit 2 I have created, right? And we will try to inherit the t-test class, right? So just I have created t-test new class, and we are inheriting the t-test class in this, and just put one procedure, right? So within the procedure we will try to access. So now I have created a object of the t variable of the t-test new class, and this is the new object. From new object, now I'm creating the object and assign to new object variable, right? And through new object, we'll see that which are the member we are able to access. Can we see that? So, see, so through new object, we will able to access the t test, right, on the members. So we will see that which are the member are accessible. So we are able to access the strict protected, right, field protected, like, so we can say that is strict protected, protected, public, okay, and after that publish. So we are not able to access basically the private and strict private. So we can conclude it here. We are able to access only the strict protected, protected, public, and publish. Four accesses where we are able to access. So what is nested class? Nested class is the class within a class. So nested classes enable you to largely group classes that are only used in one place, increase the use of the encapsulation, and create the more readable and maintainable code. A nested class, nested type can access an instance variable, field property, or method of its container class. So container class is the, we can see that the class within a class. Okay, but it must have an object reference to do so. A nested type can access the class field, class property, and class static method without an object reference. But the normal Delphi visibility rule apply here also. Like access specifier is there, that visibility rule apply. So nested type do not increase the size of the containing class. Create an instance of the containing class does not also create an instance of the nested type. So nested class type we have to create a separate instance. Now we move to the Delphi code. Here we will see that the how to create a nested class. So we can create a class, okay, t parent class, and this is the one of the strict private member I have created. Within this one public specifier, in public specifier I have created a class, again the type the child class, and one variable and one procedure in within this class. So this is the nested class, right? And after that the parent class I have created the parent procedure. Fine. So now we can create a object, right? So parent class we can directly create an object of the the parent object of type t parent class. The child object, how we can create it, with the parent class reference we have to give, then child class name. So this is the way to create the nested class. So nested class is here the t child class. So we can create a variable of like this, t parent class dot t child class, right? And similarly we create the instance also and assign to this particular object. So when you create the instance of this child class, so t parent class dot t child class dot create, right? We can assign the value, right? And after that we can access it. So this is the way to create the nested class. Now we will see that the generic, how to create the nested class in the generic. So t class, it's a generic class I have created, right? This is the one variable of t type. This is the nested class, right? So nested class I have created here. This is the nested class, and this is the way to declare the variable, right? So in this video we have seen it how, what is the nested class and how to create it, what is the use of. What is the sealed class in Delphi? So any class can be declared as a sealed class. We can not inherit sealed class in derived class. So we can't inherit any of the sealed class in the derived class, right? The compiler will return the error if you try to inherit the sealed class, right? So it will throw the error like we cannot extend the sealed class, right? So what is the purpose of making the sealed class? The sealed class is mostly used for the security reason. So we can create a class, we can declare as a sealed class where we prevent, right, to give all the method into the inherit class, right? So that the derived class can be corrupt. The implementation is provided in the sealed class, right? So this is the region, such region. This is the one of the region where the sealed class, we declare a class as its sealed class, right? So let's take one example and see that how the compiler behave. So here I have created a class, okay, sealed class, and t my class, and this is the class, and I have just written the sealed right after the class. So then this class will become the sealed class. So this is the way we need to declare the sealed class, right? Just taken one variable, and after that I am declaring another class, t my class 2, and I'm inheriting the sealed class, t my class 1 with the sealed class, right? So here I'm trying to inherit the my t my class 1, okay, and just declaring one variable. If you see that right here, it's giving the error. We cannot extend up t my class 1. That is the sealed class, right? So when you compile even, right, compile the application, it will give you the error, right? So it's giving the error. Cannot extend the sealed class t my class 1. So t my class 1 is the sealed class that we cannot inherit. Thank you very much.